Hey all, welcome. This is the final unit study guide for Unit 7. Your test is on the 5th. It's all the normal stuff here. Um, Study schedule is pretty much the same. It's uh, it's just a typo here that the review day is on the Wednesday and the test is on the Friday. That's it. Okay, we're gonna get on with it. Need to know cold. What you need to know cold here. So the areas of the geometric shape. There are different geometric shapes. This is relevant to the cross sections. You have the isosceles right, which is 1/2 x squared, where this is x, right? For you have equilateral triangle, which is root 3 over 4 x squared. You have a square, which is regular x squared. You have rectangles, which is usually some h x squared. And then you have a semicircle, which is um, x over 2 squared 1/2 pi. Okay, which then simplifies to 1 over 8 pi x squared. So these two are the same thing. Um, these are pretty much all the shapes you need to know. They might throw you something like a quarter circle, like they could do that, something like this, which in that case it's just 1/4 pi x over 2 squared, right? That'd be a quarter circle. But yeah, you have the isosceles right, equilateral, square, rectangle, and then semicircle, and then a quarter. Okay. Just make sure you're familiar with those. We'll get to that a bit later in the test. These are the 5 sections that we had. So first was calculating area in the curve. Yeah, I mean I think we're feeling pretty good about this. It's always, I think throughout this entire test, you should be thinking always high minus low and right minus left. I think that's like the key phrase I would say throughout the entire test. I'm going to keep saying this throughout the test. High minus low, right minus left. Um, yeah, I mean, we'll do some practice questions of this later. Um, there's not really a whole lot more to say here. You're integrating, right, from a to b, high minus low dx, or you're doing integrating a to b, right minus left dy. And these are like the integrals in language anyway. We'll get to that in a bit. Disk method. So disk method is taking that area that you find and then rotating it over an axis. Could be an x-axis or over a horizontal axis or over a y-axis, a vertical one. Formula is just pi integral a to b of that area squared dx, or it could be dy, right? Where this represents the radius. Okay, the washer method. So very similar to the disk method. So the difference with the washer method is when there is a gap in the area. So for example, here, if this is my shaded region and I'm rotating it around here, that there's no gap, right? I'm rotating this around the y-axis. Versus here, if I take something like this and rotate that around the y-axis, you can see there's a gap there. So we do pi integral a to b of big R minus little r, big R squared minus little r squared dx. Okay, and we'll do some practice problems with that later. Cross sections. Cross sections is really easy formula. It's just integral a to b of a of x dx. It's that easy, where a of x represents the area of a cross section. Related rates are this last thing we did in class, something with the balloon. It's different variables that are related. Their rates are related, as you can imagine the name. It is a 4-step process to draw um, draw plus label, um, write equation, derive implicitly, and then substitute. And again, we'll be doing some of those problems later. Substitute. Okay. Let's get started with some questions. Question 1. What is the area in the region enclosed by the graphs e to the x minus 2 and y equals sine x and x equals 0? So go ahead, go to your calculator, you want to plug them in, e to the x minus 2, sine x. Go ahead and graph it. I recommend you doing zoom 6 just to start out really simply. And then, so we can see here they're enclosed at this sort of center here. So I'm going to do zoom, then box, and then I'm just going to center that around here and bring it down here. I actually like misread this question the first time, and I'll show you what I mean in a second. So it says the region enclosed by the graphs e to the x minus 2 and sine x. When I first read this question, I actually thought it was talking about this top part in the above the first quadrant here, but that's not true. It would, if it wanted this first quadrant here, it would say in the first quadrant, or it would say above y equals 0, but it doesn't. It says x equals 0, which is right here, e to the x is right here, and sine x right here. If you want to tell which one's on top, which one's on bottom, go ahead and click trace, and you can see which one's on top, which one's on bottom, just like that. Okay, so we're going to do second calc intersect, and we're going to bring it all the way up here because we got to know where our integral is going to end up here, and that is 1.054. Just for like clarity, when you do an FRQ question, you would need to say e to the x minus 2 equals sine x, x equals 1.054. Like, just, it's a good habit to get into that. You have to prove how you got those numbers. You can't just plug it in for the FRQ. For the MCQ, it doesn't matter, right? So we do integral starting from 0. You can see in the graph, we go from 0 until that number, 1.054. And which one's on top? Again, if you need a refresher, if you just click trace and do up and down on the D-pad, you can see, okay, top one is sine x, bottom one is e to the x. So we're going to do sine x minus parentheses e to the x minus 2, close it, dx, that's our integral. Now we will evaluate it. Math 9, and I can actually plug in y1 and y2 for this. So my y2 would actually be first. So it's going to be from 0 to 1.054, and it's going to be y2 minus, y2 minus y1, right? Just depends on which order you have it. And remember, you should always be getting a positive answer. So we can see 0.745, that is our answer right here. Okay, number 2. The shaded region above is bounded by the graph y equals root cosine pi x over 10, and the lines x equals negative 7 equals 7, and y equals 2. What's the area of this region? So we want this shaded region right here. That's what we want. So you might be like, oh, I'm going to do like 2 on top, this on bottom, and I'm just going to integrate. But you don't need to do that. We can actually use geometry here to help us out a lot. So the area of this whole rectangle is a 2 by 14, right? We go negative 7 to 7. So it means this whole thing is 28. So if I take that 28 and I get rid of, and I subtract this area here, right, which would be the integral of root cosine pi x over 10, then I would get the area of the whole thing. Because this whole thing is 28, and I just need to get rid of this right here. So let's go ahead and graph cosine pi x over 10, root cosine pi x over 10. Let's see here. Root cosine pi x over 10 zoom 6. Always do zoom 6 just to start out with. So that's that. I'm looking at that. Let's change the window a little bit, make it it'll come to us a little bit. Y max, I can set that to 2. Y min, I can set that to -1. And then maybe I'll change my X max to 7 and my X min to -7. So let's take a look here. Okay, we can see if I trace it and I go along the curve that the bounds are going to be from 5. You can see it. You can just, by following the graph, you can just see this is 5, right? Sorry, -5 to 5. So I want to integrate from -5 to 5. So let's do that. Math 9, -5 to 5 of y1 dx. It is taking its sweet time here. There we go, 7.6. So we're going to do 28 minus that. And you can see they've got a red herring answer there. You see it? I'll show you in a second. 20.37 is our answer. They put that answer we just got, 7.628, but that's not the shaded region, that's the empty region. So our answer is 20.372. That's C. Okay, and that's area under the curve. So for that first section, for calculator anyway, expect to be able to do both of these, right? You're gonna graph it and like use the graph to figure out which one's top, which one's bottom, find the intersection, and then number 2, maybe it's like got some geometric shape in it, and so you have to use some sort of intuition. Okay. Disk method. A vase has the shape obtained by rolling the curve y equals 2 plus sine x from x equals 0 to x equals 5 about the x-axis where x and y are measured in inches. What is the volume in cubic inches of the vase? So we're going to integrate. I mean, I'll graph it in a second, but I can tell you we're going to integrate from 0 to 5, right? It's clear. X-axis, so it's going to definitely be dx. So you got to know the formula. It's going to be pi r squared, and so my function is going to be 2 plus sine x. There's no second function, so this is why it's definitely going to be disk method, and I'll show you when we look at it. So let's put it in. 2 plus sine x, 2 plus sine x, zoom 6 it, and again I'm only doing from 0 to 5. So yeah, this is the sort of the region here. Yeah, there's not much more to say. We're gonna math 9 it. Math 9, 0 to 5, 2. Put this in parentheses. 2 plus sine x squared dx, and I'll have to multiply by pi in a second here, and times pi 80.11. So it's E. Okay, pretty straightforward. That's disk. Got another one here. Number 4. Let R be the shaded region first quadrant bounded by x-axis and y-axis, and the graph of y equals 1 plus cosine x. It's the shape of a chocolate treat. By rotating around the x-axis, what's the volume? So same idea. You're taking the shaded region, you're revolving it around the x-axis. It's the exact same formula. It's going to be from integral from 0 to, okay, we do have to figure out what that is. So we need to figure out what is this. But the function is going to be 1 plus cosine x squared dx, and then it'll be pi in front. So we just need to figure out what this value is here, and then we're good to go. So let's graph it. 1 plus cosine x. Let's graph it. So we need this point right here. I can zoom in a little bit. We can take this in a little bit, or change the window a bit. So let's do it from -5 to 5, and maybe like -1 to 2. So give us like a clearer picture of it. So the region R is basically from here to here. That's R. So we can calculate the 0. I hope. So there, there, there. It doesn't like it. I think it doesn't like it because it isn't cross over. Here's like a little trick you can do if this ever happens. You can just graph a 0 in for your y2, and then you can do intersect. So you can move this over, and it will find that intersection point of 0 and the graph. 3.14 pi. That is not your answer. That is just the bound. So then we can do math9 it from 0 to pi of y1 squared dx. Oops. Enter 4.712. Okay. Did that make sense what I did there with the y setting? So again, I set y equals to 0, which is literally just like the x-axis, so that if it doesn't like cross over, you can't really use that 0 calculator function, but you can still use intersect if you make this extra function that's 0, and then you can just find the intersection point there. That's what I did. Let R be the region of the first quadrant bounded by the y-axis, the line y equals 2, the curve y equals 2 cube root x. What is the volume of the solid formed by rotating R on the y-axis? Okay, so we got a y-axis one here. Let's go ahead and put it in the calculator. So we're going to have y equals 2, and we're going to have 2, and we're going to have 2 cube root. You could either do it to the 1/3 power, or if you click math 4, there's a cube root there. Let's see what this looks like. We'll zoom 6 it. Always good to start with zoom 6. Let's see here. Oop, okay, it's really horrible. Let's zoom in on that. Zoom box. Can't see that at all. Let's go like that, that, that. Okay. Yeah, kind of a weird one here. But yeah, we're gonna be integrating from here to here. And we're going around the y-axis, so it's right minus left. So when you do it around the y-axis, it's the same idea. It's going to be pi, and then that radius squared, but then a dy. And so we have to rewrite this in terms of y. So let's do that. So we're going to have y equals 2 cube root x. We would divide both sides by 2, and I would get y over 2 equals cube root x, and then you would raise both to the power of 3, so you'd get y over 2 to the third equals x. That is my function. So that is going to be what goes in here. Y over 2 to the third. We have to get our intersection points. One of them is easy. We're going to do second, intersect, number 5 here. So remember, you're going with respect to y. It's 2. Well, that's easy. So that's 2 is the upper bound. And then my lower bound, I think I would have to do a trick for this one. So because I keep going down here, and you go to like, if I just calculate the value at 0, it is going to be from 0. So even though like it looks like it maybe intersects earlier, when I did calc value and put in a 0, my y, and I changed, when you do up and down, you can change the function. It is 0. So it is 0 to 2. And now we're ready. So we're going to put that in the calculator, but we're going to have to just write it in terms of x instead. So it's going to be math9 from 0 to 2, x over 2 to the third, all of that squared, but I need to put it on the other side too, dx. And I gotta multiply that by pi. So 0.898 b. Okay. All right, we're on washer method. 7.3 washer method. Let M be the region in the first quadrant bounded by the graphs of sine pi x over 2 and x squared. What is the volume generated when M is rotated around the vertical line x equals 2? So you want to kind of label things first, and I can put this in the calculator, but I know that this is x squared. Like this for sure is x squared. I know because I know what x squared looks like. If you were not sure, you could put in the calculator and you'd see that that's true. And then this is sine pi over 2, sorry, pi x over 2. And then the vertical line x equals 2. So we're going to go over here roughly. It's going to go up like this. Okay. This is going to be kind of a challenging one, but we'll take our time. Okay. So we need, if this is my axis rotation, I need to identify a big R and a little r. So my big R is going to be from here to the furthest, and then my little r would be from that axis of rotation to the closer one. So my big R, put it down below, you always do right minus left. Remember right minus left? So big R is going to be my right, which is 2, minus whatever this is, but I have to write it in terms of y. This is where you're not going to like this. And I didn't, to be honest, as I made this test, I did not see that you were going to have to do this. Y equals sine pi x over 2. I got to get x alone. This is where you would get stuck because you wouldn't know how to get x alone here, probably. The way that you get x alone is actually by taking the inverse sine of both sides. The inverse sine is called arcsine. So you would say, I'm going to put this in here. What you're doing to both sides is you do arcsine both sides. When you arcsine sine, sine cancels. So now I have arcsine y equals pi x over 2. And then I'm just going to multiply by 2 on both sides, and then divide by pi. So I'm going to multiply by 2 over pi on both. So it's 2 over pi arcsine y equals x. So this would be, big R would be 2 minus 2 over pi arcsine y. Little r is going to be 2 minus, and then we need to fix this one. So that's y equals x squared. This is a lot easier one. So y equals x squared, just square root both sides. X equals root y. So it's 2 minus root y. So our integral is going to be from, I assume this is 1, but I can double check that. I think it's going to be integral from 0 to 1, like this is 0, this is 1, of big R squared minus little r squared dy with a pi in front. Okay, so let's do that in the calculator. It's going to be, so we're going to have 2 minus, before I do this, I'm just going to double check that that intersection is at 1. It looks like 1, I just want to make sure it is. No, sorry, it has to be at 1. It has to be at 1 because sine only reaches maximum of 1, and that is 1. Yes, it is 1. I confirm that's 1. I don't need to do that. So it's going to be 2 minus 2 over pi, and then arc. Where do you find arc sine on the calculator? It's this one right here. Second sine. That's arc. So sine to the power of -1. This is arc sine. It's the same thing. X. That's gonna be your y1. Y2 will be 2 minus root x. Let me make sure I put parentheses around the top one right here. Kind of worried about that not coming out right. Okay, and then we'll go home, and then we'll math 9 it, and we'll go from 0 to 1, and it'll be y1 squared minus y2 squared. Oops, sorry. That's so annoying. Okay, minus y2 squared dx. Give it a minute. Okay, times pi 2.836. That is D. Okay, bit of a weird question there. Again, when I made this test, I didn't realize that this was an arc sine question. Now you know, now you've seen it. To undo sine, you arc sine it. This might be something I go over on Wednesday before the test, in case a question like this comes up. Okay, cross sections. The base of a solid is a region in the first quadrant bounded by the x-axis and the y-axis in the line x plus 2, y equals 8, as shown in the figure above. If a cross-section of the solid perpendicular to the x-axis are semicircles, what is the volume of the solid? So first things first, I just need to rewrite this in terms of y. It's kind of written weirdly. It's x plus 2y equals 8. Let's get y alone. So it's 2y minus equals negative x plus 8. So then y equals negative 1/2 x plus 4. I just rewrote that in terms of y. That's all I did there. And so we want semicircles. So semicircle is like this, and so the area of that is 1/2 pi r squared. So when we write our integral, it's going to be integral, and you can memorize it's 1 over 8, but I'm just going to write it from scratch. It's going to be 1 over 2 pi, and then my area, which is there's no bottom, so it's just going to be negative 1/2 x plus 4 over 2 squared dx. Okay, that's the pi r squared coming in here. That's the 1/2. That's the pi. That's my r squared. I'm dividing by 2 because it's the radius, right? It's this distance here. So I want to cut this distance in 2. Let's put that in the calculator. So we do, oh, and my bounds, 0 to 8. My bad, 0 to 8. It's on the picture. So it's gonna be math 9, 0 to 8. I would probably honestly just do the 1/8 thing if you remember that, but that's not what I'm doing. Negative 0.5 x plus 4 all divided by 2 squared dx, and then divide by 2, and then times pi. 16 point, there it is, C. Okay, nearly done with the calculator section here. Okay, 8. Let R be the region in the first quadrant bounded by the graphs of 4 cosine pi x over 4 and y equals x minus 2 squared. As shown in the figure above, the R is the base of a solid. For a solid, each cross-section perpendicular to x is an isosceles right triangle. Okay, and with a leg of region R, what is the volume of the solid? So you got to know when it says isosceles right triangle, know from those notes earlier. Okay, isosceles right. is like this. It means two sides are the same and it's a right triangle. So do right triangle, and the area of this is 1/2 x squared, where this is x. Okay, so pretty easy to set this one up. It's going to be integral. It's going to be a 1/2 out front, and then we're going to square the x, and the x is just going to be high minus low. So I mean, I'm certain that that's x minus 2 squared, and this is x minus 2 squared, and this is for cosine pi x over 4. If you were like not sure which one was which, you could just plug it in the calculator. But I know that's the case. I mean, let me just go ahead and put in the calculator because we're gonna have to use y1 and y2 anyway. It's probably easier. So it's gonna be 4 cosine pi x over 4, and then it's gonna be x minus 2 squared. And then we're going to, so the window pretty small. I mean, that looks fine. Okay, maybe not quite long enough. That's going to need a bigger x value. X max can be 3. So I'll show you again, if you're not sure which one's top and bottom, easy way to check is just using the trace function, which I'll show you in a moment here. If you click trace, it says on top left what the function is. So it says, oh, that is 4 cosine, and that is x minus 2 squared. So I know for sure. And the bounds are from 0 to 2. It tells me that right here. And so in my calculator, I will do math 9 from 0 to 2, and it'll just be parentheses y, oops, parentheses y1 minus y2. Let's put that in parentheses and square it, dx. Then divide that by 2. 1.775. It's A. Okay. Okay, got it. I made that one y1. I made that one y2. Always positive answers, right? Always positive answers. The base of a solid is a region in the first quadrant bounded by the graph of y equals cosine x, the x and y axes. For each solid, the cross section perpendicular is a rectangle whose height is 4 times its length. What's the volume of the solid? Okay. So first thing you want to do, obviously, is just like graph that. So it's going to be cosine x. That's just it. Cosine x. Cosine x. And that's it. Make that window pretty small, which it already is, so maybe this will be fine. And we want bounded by the x-axis, the y-axis from 0 to pi over 2. So it's this. This is the region here. See that? This is the region I care about. That's pi over 2 right there. And then we are looking for a rectangle whose height is 4 times its width. So good to draw it out. Basically, the base is x. Remember, the base is x. That's that distance between top and bottom. That's x. So like on the graph, my x is, this is my graph right here. This is my x. And it's saying that the height is 4x. The height's 4 times as big as the width. So the area of this rectangle is 4x squared. So when I integrate, it's going to be from 0 to pi over 2 with a 4 in front, and then x squared. So in this case, cosine x squared. Okay. So let's do that. Math 9 again. From 0 to pi over 2, cosine x dx, and then we're going to times it by 4. So it's 4. C. Okay, last calculator multiple choice to go. Okay, guys. So I just want to let you know, like, I'm not gonna give you a problem like that's this difficult. Like, I didn't cover this in class. Like, this is not. So I'm just gonna make that clear. A question this difficult, not on test. This is x.7. I made another like optional delta x.7, which is related rates with two equations, and this is a two equation problem. And I'll like explain it, but you do not have to watch this. Like if you want to learn it, I'm going to teach you it right now, but you do not have to know this for the test. Basically, this equation, this problem, has two formulas. There's the volume formula right here, the v equals 1/3 pi r squared h, and then there's another formula that relates r and h as they related in a cone. R over h is 4 over 12. So basically by using this equation, r over h equals 4 over 12, you're able to find r at the specific height, 5 feet, and then you're able to relate dr dt and dh dt, so that when you differentiate v here and you get this formula, you can sub in dr dt for dh dt, sorry, dh dt for dr dt right here, and then when you plug in your values, it all comes out okay. Yeah, this is like a, don't worry about this problem too much. If you're like looking to learn this, which I recommend that you do x.7, not on the test. This is a problem this difficult, not on the test. There will be related rates on the test, but not this difficult. I should have done this problem before I made the test, clearly. My bad. Um, Alright, we're going to continue with the no calculator. So calculator is going away. You should not use any calculator on these problems. So number one, we have area under the curve. This is one of the questions that I think you guys are maybe going to struggle with a little bit, because you have to use some algebra here. The area under the region enclosed by the graphs of y equals x and x squared minus 3x plus 3. So ideally you can sketch these. Y equals x looks something like that. Y equals x squared minus 3x plus 3. I don't know. I know that it's going to be kind of up here because it's going to start at 3. And I think it's going to look something like that. I think it's going to look like that, but I'm not sure. And if you didn't know, that's okay. Like, you don't have to know what this looks like to answer this problem. But what you do need to figure out is that you need to figure out what these intersection points are, here and here. You need to find those in order to answer this problem. So we have to do x squared minus 3x plus 3 equals x. You have to do that. And then, so we're going to get x alone. We're going to get x squared, sorry, 0. We're going to make it equal 0. Minus 4x plus 3 equals 0. So my factors are x minus 3 and x minus 1. So my intersection points are x equals 3 and x equals 1. And this makes sense just given like how I drew it here. So it's going to be integral from 1 to 3. This is where there's another question, which is, okay, well, which one's on top here? You know, which one's going to be on top, which one's going to be on bottom? Well, a way that you can figure that one out is by plugging in a value between these two into the equation. So a number between 1 and 3 is 2. If I plug a 2 into this one, y equals 2, okay? If I plug it into this one, it's going to be 4 minus 6, that's negative 2. Negative 2 plus 3 is 1. So I can tell you that x is going to be greater than x squared minus 3x plus 3 for this period of time. Does that make sense? So I plugged in a 2 into both of these to test which one was on top. If you couldn't draw it, you can just test a value between these two to see which one's on top. Anyway, I now know that x is on top. So I can rewrite this as x minus x squared minus 3x plus 3. Close it, dx. Simplify, we're going to get negative x squared plus 4x minus 3. 1 to 3 dx. Anti-differentiate, negative x to the third over 3 plus 2x squared minus 3x from 1 to 3. Okay, and so we're going to do it over here. We're going to do negative 3 to the third over 3 plus 2 uh, 3 squared minus 3 times 3. All of that minus, let's plug in a 1 to all this. Well, it's going to be negative 1/3 plus 2 minus 3. So, okay, 2 minus 3 is just negative 1. So it's negative 1 1/3 or negative 4/3. This is negative 4/3. Okay. Double check that here. Yeah, negative 1/3. 2 minus 3 is negative 1. Yeah, negative 4/3. So simplify this. 3 to the third, that's 27. Negative 27 over 3 is negative 9. That's negative 9 right there. Plus, that's 9 times 2, it's plus 18. And then minus 9 again. So actually, this is just 0. So my answer is minus negative 4/3, which is just 4/3. And that is my answer. I would pay a lot of attention to this question. I can tell you I'm going to give you something just like this in the test. So pay attention to this. This is a very typical AP problem. They don't tell you anything. They don't tell you which one's on top. They don't tell you the bounds. They just say, find the region enclosed by these. And so you have to find their intersection points by setting them equally to each other. You have to make sure you know which one's on top through this. And then here, when you integrate, make sure you combine like terms correctly. I guess like another solution that you could do to like the not knowing which one's on top is like you could just choose whichever one, and when you integrate it, you would get a negative answer, and you should just be able to turn that positive, and you would get this 4/3. Like if I did this the wrong way around, I should get negative 4/3 here, which would indicate it's 4/3. I would just have done it the wrong way around here. Okay, so that's my. Okay, number 2. The graphs of the function g and the line y equals x are shown in the figure above. The graphs intersect at the point 0, 0, 1, 1, 2, 2, which the following expressions give the area enclosed by the graphs. This is just straight from your notes. So um, y equals x, we know which one that one is, and then there's some other function that's called g of x. So this is g of x right here, and this is x, right? So we can see that it's like which one of these shows the right area. Well, you always have to do top minus bottom. So um, this one looks good because they're doing the top minus the bottom, and then it's top minus bottom again. They had to switch them because they cross over. So definitely 3 is good. And then this is just like you got to know it. The absolute value goes on the inside. It also works just to absolute value that inside, and that's going to get you the right answer. Okay, so 2 would also work. So it's 2 and 3. Okay. Um, all right, 3. What is the area of the region in the first quadrant bounded by e to the x over 2 and line x equals 2? So again, they don't give you anything, guys. They just give you that. So we have x equals 2 roughly right here, and e to the x over 2. I don't really need to know what that looks like. It's fine just to draw that. It's actually an easier one than the other one because there's no other function on the bottom. It's just 2. I know that's going to be 0, and it's first quadrant, so it's going to be from 0 to 2. So it's integral 0 to 2, and it's just going to be e to the x over 2. That's it. Easy. So we integrate this. This is via reverse chain rule, right? Whenever you integrate e to the x over 2, it is itself e to the x over 2. When I differentiate this, I need to get this. Currently, when I differentiate this, I will get 1/2 because I'll get e to the x over 2 times 1/2. So I have to put a 2 in front of it from 0 to 2. So it's going to be 2e to the 2 over 2 minus 2e to the 0 over 2, which is 2e minus 2. So it's A. Okay. 4. What is the area of the region in the first quadrant bounded by the graph of y equals x squared on the right and the graph of x equals 4y minus 3 for 1 to 3? Okay. So we're definitely integrating from 1 to 3. That's given to us. We are doing it, it's a right and left situation. We're just going to treat this like it's x. So think about it like it's x right now. So we're going to, I have my bounds. At this point, I just need to know which one's on the right and which one's on the left. So the one on the right, again, I can do a trick where I test a middle point. So let's put in a 2. So for that one, I'm going to get a 4. And for that one, I'm going to get a 5, right? 2 times 4 is 8. 8 minus 3 is 5. And that one I'll get a 4. So this one's further to the right. I plugged in a 2 to test which one is further to the right. 2 goes in here, 2 goes in here. So that one's further to the right. So that one's going to come first. It's going to be 4y minus 3 minus y squared dy. The rest is normal. Okay, so we're going to do, this is going to be negative y squared plus 4y minus 3 and integral 1 to 3 dy, and then we're going to anti-differentiate. We're going to get negative y squared over 2 plus 2y squared minus 3y from 1 to 3. Then we're going to plug in the 3. We're going to get negative 3 squared over 2 minus, sorry, this is to the third over 3. My bad. 3 to the third over 3 minus 2 3 squared minus 3 times 3, all minus, plug in a 1 for everything, negative 1/3 plus 2 minus 3. It's actually very similar to the other problem. I'm looking at the numbers here. Okay, what does this become? Well, 3/3 is 27. 27 3 is negative. This is negative 9 minus, this is another, it's 8 minus 18. And then minus 9 again. Sorry, I just saw a mistake. This is a plus. I just didn't copy that down right. That's a plus. This is going to be 0. This equals a big 0. It's like the other problem. Then down here, is it the same answer? It's 4/3 again. Look, it's 2 minus 3 is negative 1. Negative 1 minus, this is negative 4/3. So it's minus negative 4/3, so it's 4/3. This is 4/3. Okay, weird. It's the exact same answer as the other one. So yeah, if it's across the y-axis, like nothing really changes when you're doing the setup. It gave me my bounds here, 1 and 3. I figured out which one was on top and which one on the bottom by plugging in a 2, which is between these two numbers. So I just plugged in a 2 here, I got a 5. I plugged in a 2 here, I got a 4. Right? I got a 5. Right? So I knew that this one was further to the right. So that one came first, minus the smaller one, minus the left one, right minus left, and then just simplified, integrated, plugged in the numbers, done. Okay. Continuing, number 5. The figure above shows the graph y equals the absolute value of x, y equals 6 minus x squared from negative 3 to 2. The x coordinates of the points of intersection are x1 and x2, where x1 is less than x2. So this is just x1, and this is x2. Which of the following gives the sum of the areas of the shaded region? So again, it's just the top minus bottom that you need to know. So if we look at the first one, it says, well, this is wrong, because from negative 3 to x1, I have to do top minus bottom. So it should be absolute value of x minus the other function. So it's just like straight up wrong. This is just, I don't know what that is. I don't know what that is. This is also wrong because it's got stuff between it. It's not just root. It's not just absolute value of x. It's d, because the absolute value of x minus the bottom function. Then it's that bottom function, so the 6 minus x squared minus absolute value of x, and then we come back over here. It's absolute value of x minus that other function. So it's d. Okay. All right. We're out of the dark there of the area. Now we got some disk method. The region of the first quadrant bounded by the graph of y equals secant x at x equals pi over 4, and the axis is rotated around the x-axis. What is the volume of the solid generated? Alright, so it's going to be, since it's only one function, right, it's going to be clear to me that this is going to be disk. Right? If it's two functions, or a region bounded by two functions, it's going to be, could be washer, right? But since it's only one function, it's going to be disk. So do the setup. It's going to be pi secant x squared from 0 to pi over 4. Okay, because it's from the first quadrant and it ends at pi over 4. Right? You don't have to know what secant looks like. You do not have to know what secant looks like to answer this problem. Remember, like, secant is 1 over cosine. That's all you need to know. But you don't need that to do this problem. So this is a funny problem because squaring it helps us integrate it. What is the integral of secant squared x? Right, secant x, secant squared x, the same thing. Secant x squared, secant squared x, same thing. That's tan. This is just tan x pi times tan x from 0 to pi over 4. Okay, well, what's tan of pi over 4? Tan of pi over 4 is 1, because it's, I don't know, I just know that. It's sine over cosine. Sine pi over 4 is root 2 over 2. Cosine pi over 4 is root 2 over 2. So it's, what we're doing is tan pi over 4 minus tan 0. Tan pi over 4 is just 1. Tan 0 is, sine of 0 is 0. Cosine 0 is 1, so it's 0. So it's just pi. Pi times 1 minus 0, so it's just pi. I'm going to go over that one again because I think I kind of rushed it. Basically, we're doing disk method, so I know to do the formula pi radius squared. I plug in my radius, which is secant x. I square it. Then when I go to integrate, I can take the integral of secant squared x because I know the integral of secant squared x is tan. So we got tan from 0 to pi over 4. I plug in pi over 4 and 0 into tan. Tan pi over 4 is 1. Tan 0 is 0. You know that from the unit circle. And then pi times 1 is pi. So keep brushing up on the unit circle, guys. Keep brushing up on it. Okay. Okay, question 7 here. The region R in the first quadrant is enclosed by lines x equals 0, y equals 5, and y equals x squared plus 1. The volume of the solid when R is resolved around the y-axis is. So y-axis, that's important. I want to go ahead and do a little sketch of this. X squared plus 1. It's going to be parabola starting up here at 1. And we are going x equals 0, so this vertical line here, and y equals 5, which is roughly here. We'll call that y equals 5. This is x squared plus 1. And we are going around the y-axis, so it's going around like this, right? So we're going to set up our integral. It's going to be pi integral from 1 to 5, because I'm going from this value here to that value there, 1 to 5. And then because it's around the y-axis, I need to write it in terms of y. So over here, let's rewrite it. Y equals x squared plus 1. That's going to be y minus 1 equals x squared, root. So I have root y minus 1 equals x, right? Root y minus 1 equals x. So it's going to be integral root y minus 1, but that's going to be squared, which will be helpful to us, dy. So now that we've squared it, it's going to come out nice and clean. Integral 1 to 5 pi y minus 1 dy I'm going to take this down here. It's going to be y squared over 2 minus y from 1 to 5 with a pi out front. I just took the antiderivative there. Plug in a 5, you're going to get 25 over 2 minus 5 minus 1/2 minus 1. Okay, so let's see, 25 over 2 minus 10 over 2. I'm going to rewrite that as 10 over 2, which is 15 over 2, minus 1/2 minus 1 is negative 1/2, so it's going to be 16 over 2, which is 8. So 8 pi will be my answer for 7. So set up there, sketch it, get the bounds, rewrite it in terms of y, square it, anti-differentiate, plug in the 5, plug in the 1, combine like terms, 8, then times the pi. And that's it. 8. Yeah, just ignore all of this here. Just ignore all that. Question 8. What is the volume of the solid generated when the region bounded by the graph of x squared, the vertical line x equals 3, and the horizontal line y equals 4 is revolved around the horizontal line y equals 4? Okay, so we graph this. We're going to have x squared, and we're going to have y equals 4, which would be roughly like here. Kind of drag that up like that. And because that's going to be like 2 right here, right? Because 2 will make it 4. This is 4 right here. And then 3. X equals 3 is right here. That's x equals 3. So this shaded region here is the region. So it's always top minus bottom. So it's going to be the integral from 2 to 3. Top is x squared. The bottom is 4. And we're going to have to square all that. Dx, and put a pi out front. And that is going to be c. Okay. Top is x squared. Bottom is 4. Right, this is x squared right here. So it's top minus bottom. And it's going around 4 there. So that's it. Number 9. What is the volume of the solid generated when the region bounded by the graph of y equals 2x, the horizontal line y equals 2, and the y-axis is revolved around the horizontal line y equals 2? So we have here y equals 2x, we have y equals 2, this is our region, okay, this is y equals 2, this is y equals 2x, and then my bounds are going to be 0, and then this is going to be a 1 right here, because when I plug a 1 into 2x, I get 2. So it's going to be pi times the integral from 0 to 1 of top minus bottom squared, so 2 minus 2x squared dx. Let's go ahead and square that. You can do box method, up top, 2 minus 2x, 2 minus 2x, right? And so you get 4 minus 8x plus 4x squared, but we have not integrated yet. We have to integrate. So we're going to get 4x minus 8x squared over 2 minus 4x to the third over 3 from 1 to 0. Nice thing is when you plug in the 0, it's just 0. So let's plug in the 1. When we plug in the 1, you're going to get 4 minus 8 divided by 2 is 4. This is a plus. And then 4 thirds. And then it's when you plug in a 0, it's all zeros, so it's just a minus 0. So it's just 4 thirds pi is my answer, so it's B. Okay, moving on. Washer method. Let S be the region enclosed by the graphs y equals 2x and y equals 2x squared from 0 to 1. What is the volume of the solid when S is revolved about the line y equals 3? So it's just a setup problem, which is nice. We want to just sketch this. So 2x is like this, and 2x squared. Well, 2x squared looks like this,
This is just how it looks. But I want to make sure this is right, and I can do that by plugging in something between 0 and 1 into this. So if I plug in, like, for example, a 0.5, that would be 1. If I plug in a 0.5 here, I'm actually going to get half, because a decimal squared decreases in value. So this is correctly drawn. That's y equals 2x. This is y equals 2x squared. It is pouring with rain right now. It is the middle of the storm and the thunder and lightning. And we are rotating this around y equals 3, which is where? It's up here, right? Y equals 3 is up here somewhere. So the setup's going to be integral pi integral big R squared minus little r squared dx. So because, I mean, I can immediately eliminate e and d because it's around a horizontal line, because that eliminates those two. Hopefully you can hear me over this rain. I don't know if you can hear this rain. It's loud. And so these two. I mean, I'm leaning A and B just because of how they're written, but let's go ahead and find it. Big R is going to be that 3 minus the furthest 1, which is 2x squared, and then little r would be 3 minus 2x. So we would want to square each of those. Yeah, so it's looking like A. Yeah, it's going to be A. And again, I got the big R and little r by drawing that line from here to here and drawing that line from here to here. Okay, we're getting through it, guys. We're getting through it. 11, cross sections. Cross sections. The region enclosed for the graphs x squared and 2x is based on solid. For the solid, each cross section is perpendicular to the y-axis. The rectangle's height is 3 times its base. So, like, weirdly, this is the exact same graph, nearly the exact same graph as this one above. So you have like 2x, just like that. You have x squared that looks like that. And so it's going to be that distance, which is the integral 2x minus x. Oh, wait, which way are we? Oh, I see. Each cross section is perpendicular to the y-axis. Okay. So we have to rewrite this in terms of, if it's perpendicular to the y-axis, we got to rewrite it in terms of y. Think about it like, if it's perpendicular to the y-axis, they're going like this, those rectangles. So we got to rewrite this. So y equals x squared is going to be root y equals x, and then y equals 2x will become y over 2 equals x. So if you look at it on its side, right minus left, or top minus bottom now, the root y is on top, the y minus 2, y over 2 is on bottom. So it's going to be root y minus y over 2. And it's a rectangle, so it will be squared. And the height is 3 times the base, which means I've got to put a 3 in front. And it'll be the integral from, let's see here. Well, this is definitely 0. So where do these two intersect? 4. They intersect at 4. Right? If I plug in a 4 for both of these, they equal each other. This is 4 right here. Okay, so it's going to be integral from 0 to 4 and dy. And do I see that? Yes, that is A. Okay. All right, we are on. Okay. I think I went a little bit crazy with these cross-section questions here. The base of a solid is a region bounded by the x-axis in the graph of y equals 1 root 1 minus x squared for the solid. Each cross-section is perpendicular. Okay. All right, I got it. So I don't really care what this looks like. It's not really relevant. Um, it's above the x-axis. Hang on, we gotta draw it a little bit. Region above the x-axis and the graph y equals 1 root 1 minus x squared for the solid. This is this is a semicircle. It looks like this. How do I know that? Um, I did think just from this unit, I know that. I also know that because like I'm testing it, I'm putting in values here and seeing what happens. So if I could put a 1 in here, it's a 0. So this is 1 right here. If I put a -1, I get a 0. And I can't square root a negative number. So if I put a 3 or -3 or anything above 1 or -1 or below -1, like it goes negative, which I can't do. And then if I plug in a 0, I get a 1. So I know it looks roughly like this. So we're going to integrate from -1 to 1 this function root 1 minus x squared, but they are squares, which means I'm going to square it. So I'm going to get integral -1 to 1 of 1 minus x squared dx, which will become x minus x to the third over 3 from -1 to 1. So over here I'll do that. So it's going to be 1 minus 1/3 minus -1 minus -1/3. So 1 minus 1/3 is, that's 2/3. And then -1 minus -1/3 is -4/3. So that becomes 6/3, which is 2. So my answer is 2. So sketch it, test values to sketch it, plug it into the formula, square it because it's a square, integrate it, plug in the 1, plug in the -1, do the difference, you get the 2. 13. 13. I just had to redo this one. It's not that bad, but I made a little mistake. So x squared, okay, let me read the question. The base of a solid is the region in the first quadrant between the graph x squared and the x-axis from 0 to 1. Okay, so we drew x squared, this is 0 to 1. For the solid, each cross-section is perpendicular to the x-axis is a quarter circle with a corresponding circle center on the x-axis and one radius in the xy plane. Okay, here's the thing. When we have semicircles come out, right? We have we have to do x over 2 because we need to divide that distance by 2 to get the radius, right? But if we have quarter circles coming out, let me try and draw this correctly here. So you imagine it like this. It kind of looks like this. Then I don't need to divide that by 2 because it's already like cut in half, if that makes sense. Do you see what I'm saying? Like if it's a quarter circle, this distance, and this is what it's saying here, it's already x. So you don't need to divide it by 2 again. So it's going to be, if you think about it, the area of this section is 1 over 4 pi r squared, a quarter of a circle, right? But the r is just x because I'm not drawing a full semicircle that needs to divide that x by 2. It's just already a quarter circle, which is half of this, so I don't need to do that. Okay, so it's going to be 1/4 integral 0 to 1 x squared squared dx. So this is going to become 1/4 integral 0 to 1 x to the 4th dx, which is going to become 1/4 x to the 5th over 5 from 0 to 1. Plug in the 1. Oh, there's a pi out here, by the way. Pi. And it's just a 5th there. So what you end up with is pi times 1/4 times 1/5 is pi over 20. That's just A. Okay. The 0 doesn't matter because when you plug in the 0, it cancels out. Okay. 14. Let R be the region. in the first quadrant bounded by the graph of x squared and x equals 4 and the x-axis. Big R is the base of the solid whose cross sections are perpendicular to the x-axis are equilateral triangles. What is the volume of the solid? Sketch it. Here we go. X squared, x equals 4. Okay. So equilateral triangle from your formula sheet, you should know that's root 3 over 4 integral. It's going to be from 0 to 4. X squared squared dx. So very similar to the other problem actually. It's gonna end up being x to the fourth here, right? This is just x to the fourth. So it's gonna be root 3 over 4 root 3 over 4 x to the fifth over 5 from 0 to 4. I don't see a world where they're giving you 4 to the fifth without a calculator. Like I'm having a hard time seeing that. Although I guess technically, because you're dividing by 4 here, that's just 4 to the fourth. Okay, 4 times 4 is 16. So we got 4, 16, 64, 64 times 4. That's 240 plus 16, 256. So this becomes 256 over 5 times root 3. Again, no, I'm not going to give you 4 to the fifth or 4 to the fourth without a calculator. Okay, that's a bit much. Okay, 15. Let R be the region in the first quadrant bounded by the graph of y equals e to the negative x. The x-axis and y-axis of the line are x equals b. Okay, region R, big R is the base of the solid whose cross sections are perpendicular to x-axis are squares. As the volume of the solid is 4 over 9, what's the value of b? Alright. Sketch. First quadrant bounded by y equals e to the negative x, the x-axis, the y-axis, and the line x equals b. So there's some b over here that I don't know. And this e to the negative x, it doesn't, honestly, you can do this problem without knowing this, but it looks like this. Alright. Squares. So it's going to be the integral from 0, because it's this region here, right? I don't, if you didn't know what e to the negative x looked like, it's actually totally fine. It's kind of irrelevant. 0 to b, I don't know what the b is, of e to the negative x squared dx equals 4 over 9. So I know that equals 4 over 9. There's a problem like this in the last test, a practice test. This is a very common AP kind of style question. It's like, okay, well, what's the upper bound? If you know that the integral equals 4 over 9, then what's the upper bound? So we have to like set it up and then solve for b. It's going to be e to the negative 2x. So the antiderivative of e to the negative 2x is e to the negative 2x. But again, like whenever you take the antiderivative, you test it, take the derivative, you should get this. If I take the derivative of this, I will get e to the negative 2x times negative 2. I don't want the negative 2, so I got to multiply it by negative 1/2 to cancel out that negative 2. From 0 to b equals 4 over 9. Well, when you put the 0 in here, you'll get negative 1/2. So it's something. When I plug the b in, it should be negative 1/2 e to the negative 2b uh, minus negative 1/2 equals 4 over 9. This is so horrible, this problem, I would not give this to you guys. I would not give this to you. You would have to, this is plus a half, right? So I would subtract a half over here to get rid of that. Um, which I could write as 4/9 minus a half. I could write that as 8 8/18 minus 9/18 is negative 1/18. So now I've got negative 1/2 e to the negative 2b equals negative 1/18. Does sound a bit weird. Then we're going to multiply that by a negative 2 on both sides. So we're going to get e to the negative 2b equals a ninth. Then I take the ln of both sides. So you get negative, we take ln both sides here. I'm going to get e to the negative 2b equals ln 1/9. You guys are not going to like this. This is just gonna skip this problem. I just gonna skip this problem. 15 is out. 15 is definitely out. Yeah. So this is really 9 to the negative 1. Let me get. I'm losing my mind here, guys. Let me get some paper out here. All right, we're gonna continue like this. Negative 2b equals ln 1/9. Okay, this means ln 9 to negative 1, which means negative ln 9 equals negative 2b. Divide by negative 2, I'm totally covering up everything. Divide by negative 2, you get b equals 1/2 ln 9, which is right there. Absolutely do not do that problem. Skipping that. That's not on the test. Forget about it. Related rates. Jesus. Related rates. Okay, 16. The radius of a right circular cylinder is increasing at a rate of 2 units per second. The height of the cylinder is decreasing at a rate of 5 units per second. Which of the following expressions gives the rate at which the volume of the cylinder is changing with respect to time? Okay, all you need to do here is take the derivative of this, because it just wants you to set it up. It doesn't really want you to, doesn't want you to solve it completely. So we know that dv dt is equal to pi, and there's going to be a bit of a product rule here. So left r squared d right dh dt plus right h d left, which is 2r dr dt. And then we're just going to sub in what we're given. So we're given that dr dt is negative 2, sorry, positive 2, it's increasing at a rate of 2, and the height is decreasing at 5. So dh dt is negative 5. So let's go in here. The r just says r squared, so it's going to be pi r squared dh dt was negative 5 plus h 2r dr dt is 2. So it's times the 2 here. And pi gets distributed to both of these. So I'm going to get negative 5 pi r squared plus 4 h r pi is also in there. So that's negative 5 r squared 4 pi r h. So it's c. Okay. 17. Paint spills onto the floor in a circular pattern. The radius of the spill increases at a constant rate of 2.5 inches per minute. How fast is the area of the spill increasing when the radius of the spill is 18 inches? So circle, paint is spilling out like that, right? We got a radius
Here, we know that the radius is 18. We know that the radius is changing dr dt at 2.5. And we want the area, so on dA dt, that's what I want. So remember, area of a circle equals pi r squared. So we're going to derive that. We get dA dt equals pi 2r dr dt. So r is 18, so it's going to be 2 times 18 times 2.5. A little bit weird. This is going to be 36 times 2.5. So that's 72 plus a half of it is 18, which is 90. So this is 90, and then we got the pi from the beginning. So it's d. Okay. 18. Functions w, x, and y are differentiable with respect to time and are related by the equation w equals x squared y. If x is decreasing at a constant rate of 1 unit per minute. All right, let's put this then. Dx dt is negative 1. Y is increasing, dy dt is 4. At what rate is w changing with respect to time when x equals 6 and y equals 20? So it gave us all the values right here. Then we go back to the equation. We're going to differentiate it. So we're going to get dw dt equals lefty right plus righty left. It's going to be a product rule right here. Left x squared dy dt plus right 2x dx dt. My x was 6, so it's going to be 36 times 4 plus 20 times 12 times 4. Wait, I need to be very careful here. That's dx dt, no? Yeah, that's dx dt. So that's a negative 1 here. Okay. Again, these are big numbers for a no calculator portion, if you ask me. Let's see, that's 120 plus 24. That's 144. That's 200 plus 40. It's 240, negative 240. Let's see here. So that's gonna be 96, negative 96. Again, not gonna give you anything. I hope not to give you anything that bad in terms of arithmetic. Well, that's the multiple choice done, guys. We're on the final straight here. We're on FRQ. We're gonna finish strong here. Got one with a calculator, a couple without a calculator. I think in general, like there will, if I find that area is often with a calculator, but sometimes it's not. So we're going to cover both. So we have functions here. We have f of x equals 1 plus x plus, zoom in a little bit here, e to the x squared minus 2x, and g of x is x to the fourth minus 6.5x squared plus 6x plus 2. Let R and S be the two regions enclosed by the graphs f of x, f and g shown in the figure above. Find the sum of the areas R and S. So sum means add them, right? So we just need to find what is R plus S. So we're going to need to find the area of this and the area of this. And to do that, we're going to need that calculator. So on the calculator we go. Let's go ahead and put it in. So we're going to get 1 plus x plus e to the x squared minus 2x. And then y2, we're going to have x to the fourth minus 6.5x squared plus 6x plus 2. We'll just zoom 6. I like to start with zoom 6, and then we can just adjust from there. Okay, you can see the first one coming down there, and then see the second one coming in there. Okay, let's now zoom box this a little bit so we get a nicer picture of what's going on. So let's put it like from here, box over here, and then down, and I'll go down to the x-axis so we can see it like this one. So you can see that's the first function coming in there, and then this is our other function. Okay, so we just need to identify which one's which, just to double check. We can click trace, And so I can see that top one is the 1 plus x function, so that's the f of x. So I'm going to go ahead and label this is f of x, and this one is g of x, right, by process of elimination. And I can go up and down the d-pad to see that that is indeed g of x. Okay, so let's set up my integrals here. We're going to have the integral from 0 to some number, which we'll come to in a second, of, well, first it's going to be g of x minus f of x. Don't forget the dx, plus then an integral from some number to 2 of, other way around, f of x minus g of x. Now we need to find that intersection point. This is important, guys. You can't just like put in a number here and just like pretend that nothing happened. You have to show them that you got that value. So obviously we're going to do in the calculator intersect. We're going to go find that intersection point here. And we're going to get 1.0328. The way I'm going to show that is like, I would put it off to the side. Ideally, I would have more space, but I would say, I mean, I'll do it down here. I want to set g of x equal to f of x, and this is true at x equals 0, x equals 4, and x equals 1.0328. X equals 1.0328. Now, optional at this point, and I could set that equal to, I could say that's a, and I'll show you like how I would use that. Something you could do, optional. You do not have to do this, but you could click the stow button, or let's go to mode. So go back to home and click stow. It's going to take that point, and I'm just going to store it for a. And so now it's just going to be very, very exact. So by me saying that's me telling them I found the intersection point, I'm calling it a. And so when I plug it in here, I don't have to write 1.032. You can write 1.0328, that's fine. Like, you'll get the points. But I can just write that instead. And so now I'll do the integral, right? So it's going to be, make sure I know which one's in which, this is not a mistake you want to make. So my my f of x is y1. I'm going to put that up on here. Y1 is f of x, and then y2 is g of x, so I don't mess that up and put them in the wrong order when I'm going to integrate. It's going to be math 9 from 0 to a. It's alpha math. Remember that a is what I just stored there, and it's going to be, for the first one, it would be y2 minus y1. So y2 minus y1 dx. I get 0.99743. Okay, plus, and then I'll do my other integral. It's going to be, let's write from scratch here, math 9 from a, alpha math, to 2 y1 minus y2, and I get 1.0069. So when I add them together, plus 0.99743, I get 2.004. And that looks pretty good to me. So yeah, just always tell them what you're doing. Like, there's no harm in putting this, okay, y1 is f of x, y2 equals g. And let's check the answer key to make sure we're on the right track. I'll have, again, let me get another page out here. Yes, okay, so I got the answer key here just to double check what we're doing. And yeah, they did it pretty much the same way I did. They sort of said this in more of a sentence. where like they intersect at these specific points where I just put like the x values. I'm sure that's fine. They did it similar to me here. Yeah, and we got the same answer. Integrals and the answers are the same. Okay, that's 4 points. Region S is the base of a solid whose cross sections are perpendicular to the x-axis or squares. Find the volume of the solid. Okay, so we're only concerned about region S, which was our second integral here. So we would do the integral from a to 2 of f of x minus g of x, and since it's a square, we're just going to square it. And that's it. Easy. Look at that. So we can just go back here, and I can actually just go back to this integral here, and I'm just going to put in those parentheses so I can square it. And we get 1.283. Easy. Look at that. That's 3 points, guys. I mean, that's 7 points, right, on a test. You can see how important volume is, right? That's it. Okay. C. Let h be the vertical distance between the graphs of f and g on region S. Find the rate at which h changes with respect to x when x equals 1.8. Okay, so h is vertical distance. This is a very important concept. So we're on S, and so h is this distance here. That's h right there, the distance between these two. So what is h really? Well, h is really just f of x minus g of x. So let's come back down here. So we're going to say that h of x equals f of x minus g of x. So if I want to find the rate at which h changes at 1.8, then I'm going to want to take the derivative of h at 1.8. That's going to be the derivative of f at 1.8 minus the derivative of g at 1.8. And so this is just math 8. We're going to go into the calculator here. We're going to do math 8. And we're going to do the derivative of first f. So it's going to be y1 at 1.8. And we get 2.116 minus, and then we'll do the same thing but for y2. Make sure this is really important that you label. I would definitely label which one's y1 and which one's y2, like at somewhere on your page, so you don't make that mistake. That's not a mistake you want to make. Definitely label them. There, y2, 5.928. So we have 2.116 minus 5.928, negative 3.812. And I'm just going to drag this down here. So make sure the notation is good. So this very clear. This all logically makes sense. The derivative of h at 1.8 is this minus this, which is this. So that's fine, right? Okay. Got it. And we look at the answer key. It's exactly the same thing. Okay. To the derivative. What is h of x? To the derivative of it. And then plug in 1.8. That's it. Okay. All right, so there will be a question like this on your test. That would be a pretty straightforward area volume question. Let's look at some non-calculator versions. So for 5, this is no calculator. I cannot use the calculator for this, which is kind of jarring to you maybe. This is from 2019. Let R be the region enclosed by the graphs of g of x equals negative 2 plus 3 cosine pi over 2x, and h of x is 6 minus 2 parentheses x minus 1 squared. Find the area of R. So we need to do top minus bottom. We need to identify which one of these is g of x and which one is h of x. So you might be wondering, how do I do that? Well, a good idea is just to plug in a value into them. So if I plug in a 0, for example, plug in a 0 over here, you're going to get 0 minus 1 squared, that's 1. So that's going to be 6 minus 2, which is 4. So I can already tell just by plugging in a value that this is going to be h of x here, right? Just by plugging in a 0. So if you're unsure which one's on top, like plug in 0, plug in 1, plug in some easy numbers, see what happens here, and then just like you can see, okay, well that one's h of x, and so this one has to be g of x, okay? So let's go ahead and just write the integral. We'll get some points just for doing that. We don't want to lose any points here, so we're just going to write the integral from 0 to 2 of h of x minus g of x. That'll get us some points, even if we can't do the integration. Like that, just the setup will get you some points. But then obviously we want to do the real thing. So this is going to be the integral from 0 to 2 of h of x, which is 6 minus 2x minus 1 squared minus negative 2 plus 3 cosine pi over 2x dx. So you have options here. I mean, you could combine like terms now, or you could do it later. I kind of like to do it now, but they don't do it in the answer key that way, so I'm just going to do it the way they do it in the answer key to keep it consistent. We integrate here. You're going to get 6x minus, just add 1 and divide. This is minus 2x minus 1 to the third all over 3. This all in parentheses, minus negative 2x. And then here, this is, it's going to be a little bit of a chain rule here. Antiderivative of cosine is sine, but this pi over 2, I have to undo that, so it's going to be plus 2 times 3 is 6, 6 over pi sine pi over 2x. Okay, this is from 0 to 2. Okay. Then we'll plug in the 2. I need space for this. I need space. So let me get some paper here. So let me rewrite this. It's going to be 6x minus 2x minus 1 to the third over 3 minus negative 2x plus 6 over pi sine pi over 2x no dx from 0 to 2. Okay. And so you might be wondering, like, okay, well, you might still be confused about the 6 over pi sine pi over 2. It's just the idea is when I take the derivative of this, I should get back to where I started up here. Derivative of sine is cosine. But when I take the derivative of the chain rule, pi over 2x will be pi over 2. I do not want pi over 2 there, so we multiply by 2 over pi. And so 2 times 3 is 6. That's how we get that 6 over pi, because you're multiplying by 2 over pi. Anyway, we continue. Plug in the 2. So we're going to get 6 times 2 minus 2 minus 1 to the third over 3 minus negative 2 times 2 plus 6 over pi sine pi, because the 2's will cancel. 2 times 1 over 2 is just 1, so it's gone. Minus, then plug in a 0, so it's going to be 6 times 0 minus 2, 0 minus 1 to the third over 3 minus, this is also like all in like a big bracket, minus negative 2 times 0 plus 6 over pi sine 0. Done. This is the answer. This is technically fine. I would just leave it like this, because I think the chance of you like making a mistake as you are put that in brackets. Not that that's not a big deal. It's fine, but I would put that in brackets. Um, the chance of you making a mistake here is really big. So don't worry about it. About like about simplifying this. You can just leave it like this. You can get the points. Um, if we look at the answer key here, another good time. So they wrote the integral, right? So as we did, right? H of x minus g of x. We got that, so get a point for that. Just for the antiderivative of that one term, 3 cosine pi over 2, getting that to be 6 over pi sine pi over 2x, that's a point. And just correctly anti-differentiating the remaining terms, same thing. And the answer is just them plugging in the values like I did, but they just simplified more, and then they simplified to the end. But again, this answer is fine. My answer is fine. So I don't see a need. My recommendation to use is what I would do on the test. It's like if you get an answer like this on the test, do not simplify it. There's no point. You're just gonna make a mistake. You could, if you simplify this wrong, put the wrong answer now, no points, right? So, or no points for the answer anyway. So don't do it. Okay, region R is the base of a solid. For the solid at each x, the cross section perpendicular to the x-axis has the area A of x equals 1 over x plus 3. Find the volume of the solid. This is like this is a question that like is easy, but you might just be so confused by what this means. Remember that the cross section formula is just the integral of a to b of a of x dx, where the a of x is the area of the cross section. So the area of the cross section, it tells me it has an area of this. That's my a of x. So all this is saying is integrate from 0 to 2 um, of 1 over x plus 3 dx. That's it. So when we integrate this, 1 over x plus 3, that's ln. It's going to be ln x plus 3, absolute value x plus 3, from 0 to 2, which would be ln 5 minus ln 3. And let's check the answer key there. Again, same idea. They've got it the same integral. It's just the integral of the cross section area, and that's it. Okay. Um, C. Write but do not evaluate an integral expression that gives the volume of the solid generated when r is rotated around the horizontal line y equals 6. So let's go up to this. Let's plot roughly where. So y equals 6 is way up here, right? This is y equals 6. And we want to rotate r around that. So this is washer method, because we have an axis of rotation and we have two functions. We have an inner little r here, we got the big R here, right? So little r is going to be the 6 minus h of x. And the big R is going to be the 6, always top minus bottom, minus g of x. So now that I know those, I'll come down here. We can set up the integral pi integral. Same bounds, it's going to be 0 to 2. And then my big R is 6 minus g of x squared, minus my little r is 6 minus h of x squared dx. And that's it. I just have to set it up. I don't have to evaluate that, which is nice. Let's make sure we got that all right here. Yeah, so the limits and I assume the constant's referring to the pi. So just for getting 0, 2 in the pi, you get a point there. The form of the integrand, I assume that just means that it's something squared minus something squared. And then the integrand itself just being the right big R and the right little r. So as you can see, this problem was kind of strange. A was really quite challenging. Like, these are not easy integrals here. Obviously, a lot of points on offer, 4 points. But B and C were relatively easy. Or C is, I think C, if you understand washer method, like definitely pretty straightforward. B is like a little bit tricksy just because like it's almost too simple. You can kind of get it. But just this is a good example of like sometimes the first question is harder than the remaining two.
Alright, we're on the last one, guys. Last part of this Unit 7 video. The funnel. Alright, this is from 2016. Inside of a funnel of a height of 10 inches has a circular cross sections, as shown in the figure above. At height h, the radius of the funnel is given by r equals 1 over 20, 3 plus h squared, where we're between 0 and 10. The units of r and h are in inches. Find the average value of the radius of the tunnel. So average value, this is kind of a throwback. But you see average value, it's going to be 1 over 1 over b minus a integral a to b of whatever that thing is, f of x dx, right? So that's what we're going to do. We are just average value. You like conjure that formula from way back in your brain. Average value, you just got to know it. 1 over b minus a integral a to b of that function. So we're just going to do that. It's just going to be, what's my bounds? Well, it's from 0 to 10. So it's going to be 1 over 10 integral from 0 to 10 of 1 over 20 3 plus h squared dh. Yeah, because that's gotta match the variables. So we can take the 120 out, so it's gonna be 1 over 200 integral from 0 to 10 3 plus h squared dh. We're gonna integrate this. We're gonna get 3h plus h to the third over 3 from 0 to 10, 1 over 200, and then we'll plug in the 10. This is a good example again of like, don't simplify this. It's going to be 1 over 200 integral 30 plus 100 over 3. And then, I mean, the zeros are just going to zero out. So that's my answer. And I'm just going to leave it like that. That would be it. Let's take a look at what they did. Yes, average radius. They read the average formula, just like I did. DH. Yep. And they did that. They had the minus 0, but I didn't put that. And they put inches. That's probably a good idea to do. I'll go ahead and put an IN there. Okay, don't forget the units. Okay. So again, don't simplify. Don't be tempted. Just leave it. Don't touch it. B. Find the volume of the funnel. Okay. Well, you can see here, this is going to be a disk method because we're just rotating this around like this, right? And my radius, I have my radius written in terms of h. So I am just going to do the do the disk method on that. Again, I need some more space for this though. Alright, here we go. Volume of the funnel, it's going to be pi. Makes sense because it's radius squared anyway, so pi from 0 to 10, radius squared, which is going to be 1 over 20, 3 plus h squared, all that squared, dh. So it's kind of messy, this one. When you square this, when you multiply it by itself, you're going to get 1 over 400 here. Okay? And then you're going to have to do box method on this. Does that make sense? So when you multiply this by itself, you're going to get 1 over 400 up front. Pi, integral from 0 to 10. And then we're going to have to box method the 3 plus h squared. We're going to square that. So if we did the box method, 3h squared, 3h squared, we would get h to the fourth plus 6h squared plus 9 dh. Then we would take the antiderivative of that. We're going to get h to the fifth over 5 plus 6h to the third over 3 plus 9h from 0 to 10
and then 1 over 400 pi times all of this. Again, this is where you don't want to simplify it. So we're just going to put it 1 over 400 pi times, I'm just going to plug in a 10. 10 to the 5th over 5 plus 6, 10 to the 3rd over 3 plus 9 times 10. And then, because like when I plug in a 0 for everything here, it's just going to 0 out. I'm going to leave it like this. I'm not going to touch it. And I'm just going to say inches cubed. Okay. That's fine. I really encourage you not to simplify, not to make mistakes. Just leave it. Once it's in a form where a scientific calculator could do it, it's fine. I think that's such a stupid rule, to be honest with you, that they take points off. So yeah, they got similar things. So the same integral, they just simplified more. They just got that answer. So last one. Okay, last problem here. The funnel contains liquid that is drained from the bottom at the instant when the height of the liquid is h equals 3. H equals 3. The radius of the surface of the liquid is decreasing at the rate of dr dt is decreasing at a rate of -1/5. What is the rate of change of the height of the liquid with respect to time? So to do a related rate problem, you need a equation that relates the radius to the height. Remember, I'm looking for what is dh dt. So I need an equation that relates these two. Well, luckily, earlier in the problem, we are given that equation, r equals 1 over 23 plus h squared. So we're going to use that 23 plus h squared. We're going to use that to find dh dt. So before we take the derivative of this, I'm just going to distribute that 1 over 20, make it look a little cleaner. So it's going to be 3 over 20 plus h squared over 20. Then when I take the derivative, I'm going to get dr dt equals, that's 0, plus 2h, sorry, just 2h over 20. And now I can, nope, times dh dt. That's close. Because of the chain rule, I gotta make sure I multiply with dh dt. So now I can pretty much just solve this. It's gonna be negative, I'm gonna sub in -1/5 equals, h is 3, so it's 6 over 20. 6 over 20 dh dt. So I'm going to multiply by 20 and I'm going to divide by 6. So I'm going to get -20 over 30 equals dh dt, or I'm going to write it up here, dh dt equals -2/3 in per sec. That's it, guys.